Good morning again, Kill Kiddos. Today we're going to try to learn about the chain rule. So first of all, we're going to briefly discuss the generic look. If I have a function here, y, and it's made up of a function, f, that has another function inside, this is called function composition, and this is no joke. This is the way calc teachers teach it. This would be like if I had a function f, which was the x squared function, and a u function, which was 3x plus 5, then the expression would be to take 3x plus 5 and put it into the x squared function. Normally what I write is kind of the outer function is something squared, and the inner function is 3x plus 5. Anyhow, the derivative in this case would be the derivative of the outer function with the u function put back inside times the derivative of the u function. Alright, let's try that exact one. Y equals 3x plus 5 squared. Often it helps to identify what the outer function is off to the side. The outer function is something squared, and that's usually how we write it. The u function is 3x plus 5. Just to practice, if I gave you this expression, I said, what's the derivative of f? You could say it's 2 times something to the power of 1. Almost identical to if I asked you what the derivative of x squared was. Here the derivative of u is just 3. So you should see this pop up here in a minute. So hence the derivative of y is, you can kind of cover up briefly for a moment and ignore the fact that there's an inner function. Let's try this. So temporarily just pretend that's gone. This might work. So the derivative of the outer function, which is something to the power of 2, would be classic. Would be 2 times something. That's just this derivative. Now you take the inner function and put it back inside 3x plus 5. Then you multiply by the derivative of the inner function, which is just 3. You could certainly expand this if you'd like. This 2 and that 3 makes 6. Oops, times the quantity 3x plus 5. But for today's purposes, that'll be sufficient. I'm going to make up another one off to the side. I'll just remind you that if I give you a function that's inside another function, the derivative of y is f prime of u times u prime. But that was loud. So in this example, y equals the quantity 5x squared plus 3x plus 2 to the power of 4. Again, first you identify that there's an outer function, which is simply, in this case, x to the fourth. So hence the derivative is 4 something to the power of 3. That's the start. X to the power of 4 would have a derivative of 4x cubed. Something to the power of 4 would look like such. Now you take a look at the inside function. Put that back in there, exactly as is, 5x squared plus 3x plus 2. Now you multiply by the derivative of the inside. The derivative of 5x squared is 10x. The derivative of 3x is 3. The derivative of 2 is 0. So again, that would be sufficient. Now let's try another one. Because these just get easier and easier. Alright, this time you got to be careful on what's the inside and what's the outside. I'm going to give you a function that is y equals 3 times the quantity x cubed plus 4x squared to the power of 7. So remember, I say if I give you a function, which is composition, the derivative is f prime of u times u prime. Alrighty. So I'm going to cover in black here. And let's not forget, you have an inside function and you have an outside function. So I've erased the inside function for a minute. The derivative of 3 something to the power of 7, simply, this is just the start, this is the f prime part, would be 21 something to the 6th. The 7 goes out front, you multiply to get 21, the exponent drops. Now you still have the function, the inside part, x cubed plus 4x squared, and now you multiply by the derivative of the inside. 3x squared, and the derivative of 4x squared is 8x to the power of 1. We'll call that good. Let's try another one. By the way, on worksheet 10, this will be problem number 1. Y equals the quantity of x cubed plus 3 to the power of 5. So the derivative of the outside, so I'm ignoring x cubed plus 3. The derivative of the outside is 5 times something to the power of 4. I place x cubed plus 3 back in there. And now I evaluate the derivative of the inside, which is 3x squared plus 0. So I'll just leave that like that. We'll call that good. Alright, on worksheet number 10, let's try problem number 6. Let's give that a shot. They wrote it like a function, you'll notice. but you could just write it as, you could call it y or g, or you could call it your own name if you wanted to. And the first thing they did was have a square root of negative 2x squared plus 1. So hopefully you can see that the outer function is the square root function. I can't really do calculus on that, so I'm going to rewrite this. Instead of the square root of x, I'm going to call that something to the power of half. So I'm not even evaluating the derivative just yet. I'm just rewriting this original function as negative 2x squared plus 1 to the power of half. Now I can hopefully see that the derivative of this function, which is something to the power of half, would be 1/2 times something to the power of, remember Nick, 1/2 minus 1 is negative 1/2. I place the u function back inside, and now I do the derivative of the u function, negative 4x plus 0 technically. So that's annoying. Okay, we're going to call that good for the day. Remember, like my video, subscribe to my page. Thank you.